operating system. I am your instructor Varshata. Let's start our lecture series. Okay. So at the end of this video, you will be able to learn about these three types of different virtual machine that is used in the different languages. Java virtual machine, that is JVM, that is used in the Java. Android virtual machine, that is a Dalvik virtual machine that is used in the Android. And this is the Linux-VServer virtual machine that is used in the Linux programming. Okay, so this three topic we will see in today's lecture. In last lecture also we have seen some of the virtualization concept. So today we will see these three types of different virtual machine, that is JVM, then Linux-VServer, and then Android virtual machine, in which we will see the Dalvik virtual machine, that is DVM. Okay, so let's start with the JVM. Okay, so what is JVM? JVM stands for the Java Virtual Machine. Is the engine that provides the runtime environment to drive the data, to drive the Java code or applications. Okay, so it provides the runtime environment to supports for the Java, provides the supports for the Java code applications. It converts. What is the responsibility of the JVM? JVM converts the bytecode into the machine code, so it can be understood by the machine and can be executed by the machine. JVM is a part of the Java runtime environment. Okay, so JVM is a part of the JRE. In other programming language, the compiler produces the machine code for a particular system. However, the Java compiler produces the code for a virtual machine that is known as the Java virtual machine. Okay, so Java compiler produces this code for the Java virtual machine. Now, how JVM works? Let's see. So here in this figure, you can see ClassLoader, after that bytecode verifier, after that execution engine. So how this works? Let's see. So first, Java code is compiled into the bytecode. Okay, so Java code is compiled into the bytecode, and all of you know the bytecode is a machine independent code. Okay, so the Java code that will be compiled into the bytecode. This bytecode gets interpreted on the different machine. Okay, so this bytecode can interpreted on different machine. Why? Because it is a machine independent code. Okay, so between host system and the Java source, bytecode is an intermediary language. We can say the bytecode is an intermediary language between host system and between Java source. JVM in the Java is responsible for allocating the memory space. Okay, so the memory space, when the program is compiled, the memory space will be allocated by the JVM. So here the ClassLoader, after the ClassLoader, this program will be converted into the bytecode. Okay, so bytecode verifier, after that it gives to the execution engine for the program executions. Okay. Now next is a JVM architecture. So let's see which are the components that is included in the JVM architecture. So basically there are three distinct components that is included in the JVM architecture. First one is the ClassLoader, then is the runtime memory, and we can see the data area. Then next one is the execution engine. Okay, so these are the three distinct components, as we have seen in this figure, this distinct component that are included in the Java virtual machine. Now here you can see this is the Java virtual machine architecture. ClassLoader is there. So ClassLoader is responsible for loading, linking, and initializations. After that, runtime data area is there. That is the method area, heap area, stack area, PC register, native method stacks, all the types of locations that is done by this. Then execution engine is there. In execution engine, interpreter, GIT compiler. That GIT compiler compiles the program. Then garbage collector is there. And here you can see the native methods and interfaces there. Okay, and after that native method libraries are there. Okay, so what is the use of this each and every component? Let's see. So first one is the ClassLoader. Okay, so the ClassLoader is a subsystem that is used for the loading class files. It performs the three major functions. that is the loading, linking and initializations. Okay, so always ClassLoader performs these three major functions, that is loading, linking and initializations, because it loads the program into the memory area from where the program is going to be executed. Okay, now next is a method area. JVM method area stores the class structures like the metadata, the constant runtime pool and the code for the methods. Okay, so this method area, so JVM method area stores the class structures about the metadata. Then next one is the heap. All of you are about the heap structure or heap memory allocations. Okay, so all the objects, their related instance variables and arrays are stored in the heap memory area. This memory is a common and shared across the multiple threads. So heap memory is a shared among the multiple processes, multiple threads, from where thread or processes can access the data. Okay, so heap storage, that is a shared among the multiple threads. Now next one is the JVM language stacks. Okay, so the Java language stack stores the local variables and its partial results. So each thread has its own JVM stacks created simultaneously as the thread is created. Okay, so a new frame is created whenever the method is invoked and it is deleted when the method invocation process is complete. Okay, so the JVM Java language stack stores all the local variables and its partial results. So whenever this invocation is there, one frame is created, and when the invocation is complete, when the access of this invocation is complete, that frame is destroyed. Then next one is the PC register. Now what is the use of the PC register? Okay, so PC register stores the address of the Java virtual machine instruction which is currently executing. In Java, each thread has its separate PC register. Now next one is the native method stacks. Okay, so the native method stacks holds the instructions of the native code, depends on the native library. Okay, so it communicates with the native libraries also. Okay, so this native method stacks holds the instructions of the native codes and that depends on the native libraries. Now next one is the execution engine. It is a type of the software used to test the hardware, software and the complete system. So this is the role of the execution engine. Then next one is the native method interface, that is NMI. Okay, so this native method interface is a programming framework. It allows the Java code which is running in JVM to call by libraries and the native application. Now last one is the native methods library. This native library is the collection of the native libraries that is C, C++ which are needed by the execution engine. Okay, so it is the collection of the basic library, that is the functions that is needed for the execution of the program that is there in this library. Now next is the Linux-VServer. Okay, so Linux-VServer is a virtual private server implementation that was created by adding the operating system level virtualization capabilities to the Linux kernel. Okay, so what is the Linux-VServer? It is a virtual private server implementations that is created by adding the operating system level virtualizations capabilities to the Linux kernel. So using this way you can define the Linux-VServer. It is developed and distributed as an open source software. It is a fast, lightweight approaches to implementing the virtual machine on the Linux server. So whenever you want to define the virtual server on the Linux virtual machines on the Linux server, so at that time you can use the Linux-VServer because it is a fast, lightweight approach. Only single copy of the Linux kernel is involved while you are defining the Linux-VServer. VServer Linux kernel supports a numbers of the separate virtual servers. Okay, so if you want to install the numbers of the virtual server on a VServer, so you can use this Linux-VServer. Now the kernel manages all the system resources and the tasks including the process scheduling, memory, disk space and processor time. As you know that kernel does all the important tasks that is needed for the operating system to work, whether it is a memory management, whether it is a process management, IO management, everything that is done by the kernel. So kernel is responsible for the everything. Each virtual server is isolated from others using the Linux kernel capabilities. Okay, so each virtual server is isolated. That means it is a different operating system on that particular machine, and it is isolated from each other, that is using the Linux kernel capabilities. And this isolation, that is because of these four elements. Which are these four elements? That is chroot, chcontext, chbind and capabilities. These are the four different elements that provides the isolation of each and every virtual machine on the Linux-VServer. So let's see what is this command. Now before seeing the commands, let's see this is the architectures of the Linux-VServer. Here this is the hosting platform, and here that is a virtualization platform. Okay, here you can see the different virtual machine software is there, and this different virtual machine server. Okay, so different virtual machine server is there. So on a standard OS operating system, you can install the different virtual machine software as a server. Okay, so it is the same like that. You can install the different virtual operating system on a host operating system. For example, you have a host operating system as a Windows operating system, on which you want to install the two different operating system. One is a Linux operating system and another is a Mac operating system. So you can install it. So same way here you can install the different types of virtual servers on a one single server. So this provides the virtualization concept by adding the capabilities to the operating system. Got it? Now let's see the different commands that provides the isolations. So first one is a chroot command. A chroot command, a Unix or Linux command to make a root directory that becomes the something other than its default for a lifetime of the current process. Okay, so this is for the root directory command, and this command provides the file system isolation. Okay, so using the chroot command, file system isolation is possible. Now next is the chcontext command. So this ability, this utility that allocates the new security context and executes the commands in that context. Okay, so each virtual server has its own execution context that provides the process isolations. So for process isolations, we have to use the chcontext command. Now next command is a chbind command. It executes a command and locks the resulting process and its children into the specific IP address. Okay, so this is the work of the chbind, and this system call provides the network isolation. So network isolation is provided by the chbind command. Next one is the capabilities. Capabilities refers to the partitioning of the privilege available to the root user. Each virtual server can be assigned a limited subset of the root user's privileges, which provides the root isolations. Okay, so for the root isolations, use the capabilities capabilities concept, and for network isolations, we use the chbind. Same way, for the file system isolations, we use the chroot, and for the process isolations, we use the chcontext. Now next one is the Dalvik Virtual Machine. Now this Dalvik Virtual Machine, that is the part of the Android architecture. Okay, so as we know, the modern JVM, that is a Java virtual machine, is a high performance and provides the excellent memory management. But it needs to be optimized for a low powered handheld devices as well. Okay, so for the low powered handheld devices, that is for example your mobile phone, which have the operating system as a Android operating system. So it provides the lightweight operations, so that makes it faster and faster. So for that we provide we require this virtual machine, that is the Dalvik Virtual Machine. The Dalvik Virtual Machine is an Android virtual machine that optimizes for the mobile devices. It optimizes the virtual machine for a memory, battery life and performance. Dalvik is the name of the town in Iceland, and the Dalvik VM was written by the DM Bernstein. Here you can see this is the concept that is involved in the Dalvik Virtual Machine. Java file source code is there, that is given to the Java compiler, and it will convert it to the class file. And then Dex compiler is that it will define the Dex file, it will do the packaging of that, and then it generates the APK file. Now let's see what is the meaning of each and every this concept. First is a Dex compiler. What is the work of the Dex compiler? So Dex compiler converts the class file into the .dex file that run on the Dalvik virtual machine. Okay, so the file that is supported on the Dalvik virtual machine, that is the Dex file. Multiple class files are converted into the one Dex files. The Java tool compiles the Java source file into the class file. The DX tool takes all the class files of your applications and generates a single .dex file. It is a platform specific tool. Okay, so this is a platform specific tool that runs on the Android machine. The Android Assist Packaging Tool, that is AAPT. Okay, so full form of the AAPT, that is Android Asset Packaging Tool. It handles the packaging of the processes. So in this video, we have learned the Java virtual machine, Linux-VServer virtual machine architecture, and then we have learned the Android virtual machine. Okay, in Java virtual machine, we have seen its architecture and its different component like ClassLoader, native libraries, etc. In Linux-VServer, we have seen the different four functionalities that provides the isolations like chmod, chcontext, capability, chroots, etc. And then we have seen the Android virtual machine. In Android virtual machine, DVM is there that provides the concept of this Dalvik virtual machine, and it is responsible for the faster executions. Okay. So this is all about this lecture. Okay. So thank you for watching. We will meet again. Thank you.